I just built a RAG on a really complex document from Walmart, a multimodal document. I built this RAG in minutes and the results kind of blew me away, so I want to share it with you. What you have in front of you is a view of this Walmart document. This comes from their supply chain standards group. I skipped the step of uploading the document. It's kind of boring to watch me upload a file. I'm using our GroundX APIs for enterprise-grade RAG. This is the back-end tool, but I just want to show you something really cool. You can see in our back-end here, you can see your files. And if I click on this file that I uploaded, it shows what we call an X-ray. And an X-ray for us is, we've trained a vision model on 1 million pages of enterprise documents. That allows our APIs for advanced RAG to understand these documents, identify the tables, forms, graphics, and complicated objects that create downstream hallucination. We identify them correctly, we extract the data, and we turn it into LLM-ready data, JSON and other formats, and then you can instantly do accurate RAG chat on these documents. Check this out. See here these colored boxes. We're identifying the tables, the different tables here on this page, all in different colors. And then look at this. We're identifying this complex object. We're identifying these images. And I want to show you what these things get turned into. So take this complex flowchart here. If you click on it, we recognize it's a figure. You can see that over here. And then if I click this, this is what this gets turned into and stored in the RAG database with our APIs. Description: this flowchart outlines the process of testing national brand items in Walmart supply chain, detailing the steps from submitting a sample to determine the appropriate testing. And then you can see here, it really has the entire flowchart. If it's a new or existing item, you can, here's the criteria for it. Here's the questions that you have to answer, and then the flow. Let me show, and I'm going to show you how we answer questions on this in like 1 second. Here's this image. It's a figure. Again, we call all graphical items figures. This image shows packaging standards for supported and unsupported shrink packs. Title: Packaging Standards. The section describes supported shrink packs, require a minimum of 2 inches of high side wall, type of tray. This is all the information that's encoded. I mean, it's a ton of stuff here describing what this image is really all about. And what we're doing here is we're combining the data from this particular chunk, but we're also enriching it with information from the page and information from the whole document so that the chunk has more context and performs better in RAG search and LLM completion. All right, now check this out. Shrink wrap items can be identified by, if I look at the bottom right, shrink wrap items can be identified by the bullet hole. All right, let's do an instant chat on this. How do you identify shrink wrapped items? Give it a second to spin. With our APIs, you write all this in code, but in our backend we have a GUI to make the evals faster and simpler for you. You can see on the right side we actually give you the source code, and on the left side it creates an instant chat, but you would just copy and paste this source code into your IDE and you could run the same thing yourself in whatever environment you want. How do you identify shrink wrapped items? GroundX, in this case that's the name of our APIs, it thinks I'm GroundX, but identifies shrink wrapped items by looking for bullet hole seams on each side of the carton. This method is outlined in the shrink wrap identification section of the packaging standards document. Here's the actual document. Here's, boop, shrink wrapped items can be identified by the bullet hole or seams on each side of the carton. Completely correct. Let me show you something else. Let me move this here. If you do use our search feature here, you can see the actual retrievals that get returned underneath. How do you identify a shrink? What was it called? Shrink wrapped item. Okay. So in this case, oops, sorry. How do you identify a shrink grabbed item. And click here. So in this case, this is just doing RAG search. It's not sending the retrievals through to the language model to do a completion, but allows you to see how things work in the pipeline. And what gets returned are all the different retrievals. Now this is verbose, but if you'll see here, return the result. Here's the question, the query. Here are the results. These bounding boxes are literally the boxes that you saw drawn on each page. So we show you exactly where these objects come from. The document ID. Here's the multimodal URL. Okay. This should be literally the picture that we saw in the PDF. So if I create a new document here, a new window rather, and pull it up, boom. Literally the cutout of that object. So if you want to do multimodal chat, it's ready right here with the APIs. You get the multimodal objects coming out of the retrievals, and you can put them, display them however you want in your multimodal chat directly in the chat stream, or you can put it in like a sources panel on the right side, and you can accurately answer the question. It's really pretty astounding. I want to show you one more magic trick. All right, you remember this complex flowchart, right? So I'm going to ask the bot to give us the pathways for brand testing, brand transit testing, whatever that is inside the Walmart universe. All right, so if we go back to our file here, and we'll do another chat. You can just hit chat. It instantly creates a chat. This is actually using GPT-4o 32K, which we provide for free for you to do your evals. Describe in detail the pathways for, what was it called again? Here's the document. It was called brand transit testing. Brand transit testing. All right, let's give this a few seconds and see if we hit magic twice in a row. Boom. Now, think about what's happening here. Okay, this is RAG on a very complex multimodal object. All right, this is identifying this chart, breaking it down in LLM-ready data, and then making it available for RAG search, and then able to have an accurate response on this complex information. And if you look here, what the answer was, the pathways, first you do this initial item assessment, then you do this SIOC requirement check, and here are the rules about that. If you look at the original document, you know, yes, you have to do this, look, SIOC requirement check. And then it actually knows that the rules for that requirement check are up here. It's pretty great. And over here. And so it's figuring that all out. And then you have to determine these different attributes. Really incredible answer. Here's where you submit the testing results to. Just a kind of unbelievable answer that's pulling multiple positions from this document. And our RAG search and completion are giving you really sharp results on this. So this is an awesome result. Anyway, come by EyeLevel.ai, like your eyeball, EyeLevel.ai. You can test your documents for free. Sign up for an account. You get 5 million tokens of free ingest to get yourself rolling. I think you're going to love the results. And by the way, this is all built on fine-tuned open source models in Kubernetes. You can run it in our managed cloud. You can run it in your hybrid cloud or managed cloud. You can even run it in air-gapped iron in the bunker in the basement. Whatever you got, you can run this. It's enterprise-grade RAG. APIs for enterprise-grade RAG. Come by, check it out. I'm Neil from EyeLevel. See you soon.